Hello students, welcome to the next lecture series of Basic Electrical Engineering. Today we are going to see the problems on DC generators. Problems on DC generator which are asked in the previous question papers. So before going to solve this problem, let us see what are the formulas you have to remember. So what are the formulas to be remembered for the solving of these problems. Okay, first formula, that is, what is that? You got Eg is equals to phi nz by 60 into P by A. So where P is equals to A for the lap winding, A is equals to 2 for the wave winding. So this is, we are already seen. So what is the EMF equation of DC generator? Next formula you should remember, that is based on the types of DC generator. Based on types of DC generators. Based on this, so we have seen different types. One is separately excited, series self excited. In the case of self excited, we have shunt generator, series generator and compound generators. So these are the different types of formulas you have to remember in the case of the DC generator. Before going to solving of the problem, so what you have to do, the first step is draw type of generator which is given in the problem. Okay, draw type of generator which is given in problem, so that you can remember so which formula we have to apply. Okay, let us write the formula of the separately excited. So separately excited DC generator, the formulas. So we are already written as Eg is equals to V plus Ia Ra plus brush drop, and if you multiply, that is with Ia on both sides, V into Ia plus Ia square Ra plus Ia into brush drop. So this is, we are already written. Next take the another self excited motors. Now in the self excited motors, first we will take the shunt motor. So in the case of the shunt motor, the formulas to be remembered is Eg is equals to V plus Ia Ra plus brush drop. Okay, next ISH or IF is, that is V by RSH, and Ia is equals to Ia is equals to IL plus ISH. Okay, next is last formula, that is Eg into Ia is equals to V into Ia plus Ia square Ra plus brush drop into Ia. This terminology I already explained in the video, you can see in the video. Next let us consider the series generator. In case of series generator, we can write it as the line current is equals to series field current is equals to armature current. Let us consider it as I. So EMF generated, we can write it as V plus Ia into Ra plus Rse. This is plus brush drop. This is already explained in the video. So Eg into Ia, V into Ia plus Ia square into Ra plus Rse plus brush drop into Ia. So this is the, here one thing you have to remember, here you can multiply with the Ia square Rse only. Okay, so this is the brush drop into Ia. Next, in the case of the compound generator, so we have first long shunt connection. So in the long shunt connection, we have formulas are IA is equals to IL plus ISH. Next, IA is equals to, that is series field current, ISE. Next is EMF generated is equals to V plus IA RS plus RSE into plus brush drop. This is the different formula. Next is short shunt compound generator. In case of short shunt compound generator, so IL is equals to ISE. Next, IA is equals to IL plus ISH. Next, ISH is equals to EG minus IARA minus brush drop divided by RSH, or otherwise V plus we can write as ISE RSE divided by RSH also we can write. Next, final formula, that is EG is equals to V plus IL RSE plus IARA plus brush drop. And the terminology what I have used in all these formula I am writing here once again. IA is the armature current. IA is the armature current. Next, ISH is the shunt field current. Shunt field current. Next, IL is the load current. Next, EG is equals to EMF generated. V is the terminal voltage. V is the terminal voltage. RSH is the shunt field resistance. Shunt field resistance. Next, RSE is the series field resistance. ISE is the series field current. Series field current. Next, B comma D is the brush drop, brush contact drop. See, brush contact drop, whenever it is given in the problem only you have to consider, otherwise you can neglect. I think so I have covered all the terminology what I have used here. Okay, so this is the terminology we are using for the problem solving. See the problems now. So this is the question is given in January 2020 of 2018 scheme. See this problem how we are going to solve. A shunt wound DC generator delivers 496 amperes at 440 volts to load. The resistance of the shunt field coil is 110 ohms and that of armature winding is 0.02. Calculate the EMF induced in the armature. So if you observe, first what I told, first you have to draw the type of DC generator. So it is given a shunt wound DC generator. So that's why I am drawing the type. Shunt wound DC generator means this is the shunt wound. If the field winding is connected in parallel with the armature, then we can call it as the shunt wound DC generator. Here you can observe. So this is the EMF generated here, EG. Next, the armature current is IA. At this point, so the current is dividing it as, that is the shunt field current ISH, and the load current is IL. So here load current, and you have the terminal voltage it as, you have the terminal voltage V. So here you can take it as V. So you have to draw the first type of the DC shunt generator what is given in the problem, so that you will get understand. And the given information I am writing here, delivers, this means, so delivering it is how much, 496 amperes. So it is delivering 496 amperes. So we can write it as, that is the current to the load. So IL we are writing it as 496 amperes. Next, it is delivering at 440 volts. The terminal voltage is given as how much? The terminal voltage is given as 440 volts. Next, the resistance of the shunt field coil. So RSH is given as how much? That is 110 ohms. Next is armature winding resistance is given as 0.02. This is the given information. So he is asking what is the EMF generated. So before going to the EMF generated, let us calculate what is the ISH. ISH formula we are given it as V by RSH. V is the terminal voltage. Terminal voltage is 440 and RSH value is 110. So you are going to get the ISH is 4 amperes. Why we are calculating ISH? So to calculate the armature current, IA is equals to ISH plus IL. Okay. So ISH is 110. Sorry, ISH is how much it is? ISH it is given as, so 4 amperes we got, and IL load current is given as 496. Total it is 500 amperes it is supplying. That is the armature current. So EMF generated, we can write it as, in case of DC shunt generator, that is V plus IARA. Because here brush drop is not given, I am not neglecting the brush drop. Okay, you can also neglect. Then you can write it as 440 is the terminal voltage and 500 is the armature current, and the armature winding resistance is 0.02. Let us calculate 440 plus 500 into 2 by 100. So you are going to get it as approximately 450 volts is the EMF generated. This question was asked for 6 marks. Very simple question. See the next question. A 4-pole lap wound DC shunt generator delivers 200 amperes. Okay, so it is delivering 200 amperes at the terminal voltage of 250 volts. It has field and armature resistance of 50 ohms and 0.05 ohms respectively. Neglect the brush drop. Calculate armature current, next current in parallel path, next EMF generated, then power developed in the armature. See this question, this is given in September 2018 scheme, which is very latest paper. That means supplementary exam it is given. See this question, how to solve. A 4-pole lap wound DC shunt. Once again you draw the type of the DC generator. So lap wound DC shunt generator, that means shunt generator means if the field winding is connected in parallel with the armature, then we can call it as the shunt generator. So this is the diagram. Next, let us represent armature current. Here the field current is ISH, next is the load current is IL, and you have the terminal voltage is V across the load here. So this is the terminology, and EMF generated is EZ and RSH. Okay, so see the how to solve this problem. So a 4-pole lap wound. Okay, so first it is given number of poles are 4 and the lap wound DC shunt generator delivers 200 amperes. Delivers 200 amperes means it is a, so IL is the 200 amperes it is given. Next the terminal voltage is given as 250 volts. It has the field and armature. Field resistance is given as RSH is 50 ohms and the armature resistance is given as 0.05 ohms respectively, and he is given that neglect the brush drop, so no need to consider the brush drop, and calculate. So calculate, finally is asking armature current per parallel path, EMF generated, power developed. So here first we will calculate what is the armature current. Let us take the first one, armature current. So for armature current we have the formula of, so IA is equals to, we can write as ISH plus IL. IL already it is given, we have to calculate ISH value. So for ISH is equals to, we can write as V by RSH. V by RSH. V is how much it is given, 250 volts, and RSH value is given as 5. So you will get it as 5 amperes. That is the ISH value. Now calculate what is the armature current. IA is equals to, we can write it as ISH is how much it is given, we got 5 amperes, and IL is given as 200. So finally armature current is 200 amperes. So that is the first problem. See the second one, current for each parallel path. So current for each parallel path, current for parallel path. So here armature, total armature current you got it as IA is equals to 200 amperes, sorry 205 amperes here, and he is asking what is the current for each parallel path. So current for each parallel path is IA by A. In case of lap winding, A is equals to P, we are already discussed. So that is 205 divided by P, we can write how many number of poles are there, that is how much, 4. So you calculate the 205 divided by 4, how much you got, that is 51.25 amperes current in each parallel path. Next you see the third one, EMF generated. What is the EMF generated? That is EG is equals to, we can write as V plus IA into RA. He is given the neglect the brush drop, so we will get it as, that is V is the terminal voltage 250 plus armature current you got it as 205 into what is the armature resistance, it is given 0.05. So 250 plus 205 into 0.05, you will get it as approximately 260.25 volts. That is the EMF generated. Next, power developed in armature. So power developed, that is power developed means you have to calculate the armature power developed, that is EG into IA. Power delivered means V into IL it will comes. Power developed means EG into IA. This terminology I already given in the previous videos. EG into IA. What is the EG you got? 260.25 into what is the IA? It is 205. So let us multiply, that is also 260.25 into 205. So you will get it as 53.35 kilowatts. That is the power developed in the armature. Next question, a shunt generator has 4-pole lap wound armature having 24 slots with 10 conductors per each slot. If the flux per pole is 0.04 and the speed is 1500 rpm, calculate the EMF generated in the armature. What would be the generated EMF if the winding is wave connected? This question is given 2019-2018 scheme, and see the previous one, it is given for 8 marks, okay, very latest paper, right? This is given for 6 marks. Now let us see how to solve this problem. So shunt generator, I am not drawing once again, so not drawing the shunt generator diagram, so you draw once again. So let us draw shunt generator diagram. For your sake, once again I am drawing shunt generator. Here it is given the load, okay, so you know the all formulas. Now shunt generator has 4 poles. So first it is given as 4 poles. Next is given information I am writing, lap wound, 24 slots and 10 conductors, 24 slots, 10 conductors for each slot. Next is flux per pole is given as 0 for 0.04 webers. Next, speed is given as how much? Speed N is given as 1500 rpm. Right, calculate the EMF generated. So what is the EMF generated? From the given information, you have to see which formula you have to apply here. So from the given information, you can see phi n z by 60 into P by A. Whether all information is given, flux is given for us, next speed is given, next total number of conductors is given, and P is given, and lap winding. So everything is given. We can apply that formula. First formula, EZ is equals to phi n z by 60 into P by A. So what is the phi value? Phi value it is given as 0.04 and the speed is 1500 rpm. And what is the total number of conductors? See here, a trick is given, that is some logic is given for calculation of total number of conductors. here 24 slots are there. Okay, so we have the 10 conductors per each slot. So if you multiply with 10 conductors per each slot, the slots will get cancelled. How many conductors are there? 240 conductors. So total how many conductors? 240 divided by 60 into, here it is a lap connected. In case of lap connected, P by A, we will get it as P by P only. So it will get cancelled because they both are equal. So finally you do the answer, that is 4. So you will get it as 4 by 100 into 1500 into 4. 16 into 15, 16 into 15. So you will get it as 16 into 15. How much? Answer, that is 240 volts. So this is when it is connected, the lap winding, and he is asking what is the EMF generated when it is wave connected. So let us do the wave connected. So when it is a wave connected, so what is the change? A is equals to will become 2 only. So phi is 0.04 and 1500, and you got it as 240 divided by 60 into P is number of poles is given as 4 and number of parallel paths are 2. So into 2, whatever you got here, so you have to multiply with 2, that is 240 into 2, that is 480 volts you are going to get. That is the question is asked for 6 marks. So if you observe here, when it is a lap connected, you have the less voltage. When it is connected, wave connected, it is having high voltage. Okay, that is what we are already told. So it is useful for lap connected winding, is useful for so less voltage and high current application. Here wave winding is used for high voltage and low current applications. See the next problem. A 4-pole DC generator having a field and armature resistance. Just I am studying the question. A 4-pole 100 volts shunt generator with lap connected. So DC shunt generator, armature having field resistance and armature resistance of 50 ohms and 0.1 ohms respectively, supplies a load of 60 lamps and each lamp rated 100 volts 40 watts. Calculate the total armature current, the current per path and the generated EMF. Allow the contact drop of 1 volt per brush. So this is the one type of model question. This is given in January 2019-2017 scheme for 8 marks. So let us draw first type of generator. So the type of generator is given as once again the shunt generator. So here shunt generator. So and the load is given as some 60 lamps. We will see the load what is given, it is given. Okay. See let us write the information given here. First we will write. So it is a P is equals to number of poles are 4 and 100 volts. The terminal voltage is given as 100 volts. Next is shunt generator and it is a lap connected. Okay, having a field and armature resistance. So RSH is given as how much? 50 ohms and RA is given as 0.1 ohm. Supplies a load of 60 lamps. Each lamp rated is 100 volts. So let us calculate the load current. So each lamp is 100 volts and 40 watts. So let us see 40 into how many lamps are there? 60. Each is 40 watts, 60 lamps are there. So but I want to get the current means multiply, divide by 100, right? So how you got this is, so V into IL is the power delivered. V is the power delivered. Power delivered is already given. So how much is power delivered for each lamp? That is 40 watts. Okay. Next V is the terminal voltage, that is V is equal to 100 and IL is the, so here we have 60 bulbs are like this, 60 bulbs of each 40 watts. So the total power developed is 40 into 60. So IL is equals to, we can write as 40 into 60 divided by 100. That's in that way we are written. So we are going to get IL is 24 amperes. So the load current you got it as 24 amperes. Next, calculate the armature current he is asking and current per path, the EMF generated. Allow the brush drop is 1 volt. So first we will calculate the armature current. Armature current is IL plus ISH. So ISH formula you already know, that is V by RSH. V is how much? V is given as terminal voltage is given as 100 volts and RSH value is 50, that is ISH is 2 amperes. So armature current is equals to, we can write as 24 plus 2, that is 26 amperes. Next is another question is asking current per path, current for each parallel path, current per path. So here lap winding, you know A is equals to P. So IA divided by P is how many number? It is given as 4, that is 26 divided by 4. 26 divided by 4 you calculate. So what is the answer you are going to get? That is 6.5 amperes. 6.5 amperes. Next is the generated EMF. EG is equals to, we can write as V plus IARA, and the brush drop it is given as, you have to consider brush drop. So V is given as how much? 100 volts and IA value is 26 into RA value is 0.1. Brush drop is minimum, we will take 2 brushes, that why per brush how much of drop is there? 2. So 2 is the voltage brush drop, because we will consider minimum 2 brushes, so that you are going to get 2. So 100 plus 2.6 plus 2, that is I think so 104.6 volts you are going to get, that is the EMF generated. This question is asked for 8 marks. See the next question. A 4-pole lap connected armature has 960 conductors, a flux of 40 milliwebers per pole and speed is 400 rpm. Calculate the EMF generated if the armature were wave connected, at what speed must it should be driven to generate 400 volts. First we have to calculate the EMF generated. So let us calculate the EMF generated. So how many number of poles it is given? 8 poles. Next is a lap connected. Okay, lap means A is equals to P. Next is armature conductors has 960, that is Z is given as 960 conductors. Flux phi is equals to 40 milliwebers. Next is and speed N is equals to given as 400 rpm. Calculate the EMF generated. So EMF generated is, we can calculate, that is phi NZ by 60 into P by A. So here A will get cancelled, 40 into 10 to the power of minus 3. So how will get 40 divided by 1000? So you will get it as cancel, that is we can write as 0.04. So directly I am writing here 0.04 into speed is given as 400 rpm. Next is how many number of conductors? 960 divided by 60, that is the EMF generated. First we will calculate the EMF generated. So that is, what is EMF generated? So 6 ones are 6 19s, I think so. Okay, so let us multiply 400 into give the time to do the calculation into 19. So you will get it as 304 volts is the EMF generated. So if the same generated is armature is wave connected, at what speed must be driven to generate 400 volts? So if the armature was wave connected, so if the armature is wave connected, so what will happen? If the wave connected means, we will get it as A is equals to 2. So if that armature is connected, wave connected, let us calculate first EMF generated. So that is EMF generated is, we got it as 304 volts. From this only we got 304 volts. It is a wave connected means, so what you have to do, the change, that is phi NZ by 60 into P by 2. That is the change you have to make. So what is the phi you got? 0.04 into speed is how much? That is 400 into conductors are 960 divided by 60 into P is given as 8 into 4. So sorry, into 2. So you have to do this entire answer, you got already this entire answer. So that is 304 you got into 4 you have to do. 304 into 4, how much you are going to get? That is 1216 volts. So this is the EMF generated when it is the wave connected. So how how much, if the armature is wave connected, at what speed. Okay, so to generate, so 400 volts. Okay, this is the when it is connected in wave connected. So to generate 400 volts, next see the problem. To generate already 400 volts, how much speed it should be driven. So 400 volts it is given, phi is given as 0.04 and n you is asking, and 960 conductors divided by 60 into 8 by 2. So this is the question is asked 4. Okay, so this question you have to do 400 into 60 divided by 0.04 into 960 into 4. This is the speed. So this is the speed you are going to get. So 400 into 60, that is 24,000 divided by finally 0.04 into 960 into 4. How much? 153.6. Let us divide 24,000 divided by 153.6. So what you are going to get? That is the speed you are going to get it as 156.25. So always the speed will be in round of figure, 157 rpm. This is the question it is given. See the next problem. So this is the 8 pole DC shunt generator has 500 armature conductors and useful flux per pole is 0.05 Webers. What will be the EMF generated if the lap connector runs at 1000 rpm? At what speed it should be driven to produce the same EMF if at is wave connected? This is the question is given. Okay, see this problem. So just I have written entire information what it is given. Z is equals to total number of conductors it is given, and flux per pole is 0.05 Webers, and the speed is 1000 rpm, and A is the P, that is a when it is, so which type it is, lap connected winding. So Eg is equals to 0.065 1000 into 500, just I am substituting the all values, and P by A. So if you do this answer, you will get it as 541.66. And in the problem, if you observe here, at what speed it must driven to produce the same EMF. So the same EMF we have to take. So that's why I have taken the same EMF, but it is a wave connected. Wave connected means what is the change here? What is the change? A is equals to 2 it will become. So 541.66 into 0.065 into n into 500 divided by 60 into 8 by 2. We are going to get that change. So what is the speed here? Speed you can get it as 249.99. You will get approximately, we can take it as 250 rpm. That's all in this video. So if you are seeing the first time this channel, please like, share and subscribe the channel, which are very useful for external exams also. So share it to your friends also, which is useful. Thank you very much.